Good morning students. Last class we discussed about integers on number line operations and by using multiline cube and how to add and how to subtract two integers either positive or negative. Today we will discuss about some properties of integers. First property, closure property. Under addition, okay, already in previous classes we studied about some properties based upon whole numbers. In integers also we have some properties: closure property, commutative property, associative property, distributive property. Like in that, first property is closure property under addition. Then if any two integers a and b, if any two integers a and b, the sum of a plus b is equal to, for example, c, then a is one integer, b also one integer, and c also one integer. This is the closure property under addition of integers. The general form of closure property, a plus b is equal to c, means the sum of two integers also a integer. The sum of two integers also an integer. For example, here 1 plus 2 is equal to 3, like that. Minus 2 plus 4 means minus 2 plus 4. Here minus 2 plus 4, here we are applying addition operation only, but two integers are different symbols. They are having two integers are different symbols. Then we apply subtraction operation. 4 minus 2 is 2 value, and the higher value symbol is plus. That's why answer also plus, means 2 also one integer. I repeat, the sum of two integers also an integer. This is the closure property. For example, if you add any two numbers, either positive or negative and 0, compulsory we will get one integer only. This is the closure property under addition. We have to take positive integers, we have to take negative integers, and 0 also we can take. 0 plus 8 is equal to 8. 8 an integer. 8 an integer. This is the property, closure property under addition of integers. Next property, closure property under subtraction. Closure property under subtraction. Here also same, the general form, a minus b is equal to c. A minus b is equal to c means the difference between two integers is also an integer. The difference between two integers is also an integer. Want to take, for example, 7 minus 5 is equal to 2. 7 also integer and 5 also one integer and 2 also one integer. In whole numbers, this not applicable. This property, means closure property under subtraction, is not applicable to whole number. Why? Because in whole numbers we are taking 2 minus 7. For example, 2 minus 7. 2 minus 7 actual value means 2 is a positive and 7 is a negative. 2 minus 7 is not possible. That's why I have to take subtraction 7 and 2. Then value is 5. The difference 5 and symbol is minus. Why? Because the higher value is 7. The symbol of 7 is minus. In whole numbers, is not there negative numbers. Whole numbers is 0 and positive numbers only. That's why the closure property under subtraction is not applicable in whole numbers. The closure property under addition is applicable. The closure property under subtraction is not applicable in whole numbers, but integers, closure property under addition and under subtraction is applicable. Both is applicable in integers. Want to take one more examples? Here -5, this is an integer, not whole number. Next, one more example. -7, -9. I am taking two integers, negative integers. I am taking two negative integers. See here -7 first. Here two symbols is there, minus into minus, plus. Okay. Here two different symbols is there. Two different symbols. 7 is a negative integer and 9 is a positive integer. Then obviously we are using subtraction operation. 9 minus 7 is 2. Finally symbol. The higher value is 9, the symbol of 9 is plus, that's why answer also plus 2. Plus 2 is nothing but integers. This is the closure property. Closure property is nothing but the sum of two integers is also an integer. The difference between two integers is also an integer. This is the closure property under addition and subtraction. Next property. Next property, commutative property. Commutative property. Commutative property, first under addition. Under addition. Commutative property is nothing but take any two integers a and b. The sum of two integers also is equal to the reverse order. A plus b we can write b plus a. A plus b we can write b plus a. Then the two numbers, the two integers are verified the commutative property. We are writing like that. We are writing like this. Then the commutative property, according to commutative property, we can write like this. For example, 3 plus 7 is equal to 7 plus 3. 3 plus 7 is equal to 10. 7 plus 3 is also 10. One more example. Minus 4 plus minus 1 is equal to minus 1 plus minus 4. Minus 4 plus 1. Here I am taking two positive integers. Here I am taking two negative integers. Minus 4 write as it is, plus into minus, minus 1 is equal to minus 1 write as it is, plus into minus, minus 4. Then already we know what is the difference, the sum of two negative integers. The sum of two negative integers also is addition. We applicable the same symbol, means minus 5 here is equal to minus 5. This commutative property under addition is verified. Like that, one more example I will take. One positive integer, one negative integer. Example 3, one positive integer. Let an example, minus 3 plus 4. What is the value? Minus 3 plus 4 is equal to plus 1. Like that, 4 plus minus 3 is equal to 4 plus into minus, minus 3 is equal to 1. Observe here, I am taking minus 3 plus 4. One negative integer, one positive integer. Then minus 3 write as it is, plus 4. 4 and minus 3. See, two are different symbols. That's why we applied subtraction operation. And 4 is the highest value. The higher value symbol is plus. That's why answer also we are getting plus. Next, 4 plus minus 3. We are taking reverse. A plus b is equal to b plus b. B plus a, like that. 4 plus minus 3. Then 4 plus, as it is 4 plus, right? Plus into minus, minus. 4 minus 3 is equal to 1. Means LHS is equal to RHS. Means according to commutative property in integer under addition, This property is verified. Next, under subtraction. For integers, this property is applicable. Under addition. Next, we will check under subtraction. Under subtraction. Under subtraction, general form means a minus b is equal to b minus a. A minus b is equal to b minus a. The commutative property under subtraction is not applicable to integers. Why? Because a minus b is not equal to b minus a. See, take some example. First I am taking two positive integers. 7 minus 3 is equal to 3 minus 7. Both are equal or not? We'll check. 7 minus 3 means 4. 3 minus 7 means minus 4. Both are not equal. Both are not equal. That's why this commutative property under subtraction is not applicable to integers. Next, one more example. Minus 2 minus of minus 1 minus 1 minus of minus 2. I am taking two negative integers. The difference between two negative integers I am taking. See, minus 2 minus into minus plus 1 is equal to minus 1 minus into minus plus 2. Minus 2 plus 1 means the bigger value is 2, symbol is minus. During subtraction means we will get answer 1. Here bigger value is 2 or this symbol is plus, answer will come means not equal. Minus 1 is not equal to plus 1. That's why this commutative property under addition is not applicable in integer. We'll take one more example. Seven minus of minus 4 is equal to minus 4 minus 7. 7 minus into minus plus 4 minus 4 minus 7. 7 plus 4 is 11. Minus 4 and minus 7 is minus 11. See, here minus into minus plus 7 plus 4 is equal to 11. Here minus 4 and minus 7, two symbols are negative. That's why we add this two number and we'll get symbol is negative minus 11. Minus 11 is not equal to plus 11. According to observing of the three examples, the in integers is not applicable closure property, this commutative property under subtraction, only applicable commutative property under addition only. Next property, associative property. Associative property. First, under addition. Associative property under addition. See, associative property means a plus b plus c is equal to a plus b plus c. If a comma b comma c, three integers, we can write a plus b plus c is equal to a plus b plus c. Actually, the sum of three numbers. For example, we have three numbers. We have to add the three numbers. Compulsory, in the out of these three, we have to take any two numbers. That is the first number and second number. Otherwise, second number and third number. Otherwise, first one and third number. Let's take example. 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. 1 plus 2 plus 3. 1 plus 2 plus 3 means 5. 1 plus 2 means 3 plus 3. 1 plus 5 is 6. 3 plus 3 is 6. Then LHS is equal to RHS. According to associative property, we can write any three integers. A plus B plus C is equal to A plus B plus C. Why? Because different we have to think the sum of any three numbers, we have to add first number and second number is one way, and second number and third number is one way. That's why in integer the associative property under addition is applicable for addition. Next we have to check subtraction. Associative property under subtraction. Here also we have to take three integers, a minus b minus c, a minus b minus c, but first I am taking b and c is one pair, next a and b one pair. Just we have to check. Why? Because this both are equal, then associative property under subtraction also is applicable in integers. We'll take three values, 7 minus 2 minus 3. A is equal to 7, B is equal to 2, C is equal to 3. I am taking one example, 7 and 2 and 3. The associative property also same like as some commutative property. 7 minus 2 minus 3. 7 in 2 minus 3. Actually according to Bodmer's rule, first of all we have to operate first bracket values. 2 minus 3 means minus 1. Why? Because 2 minus 3, the negative value is more, positive value is less, that's why symbol is minus, and the difference between 3 and 2 is 1. Next 7 minus 2 means 5 minus 3. 7 plus into plus, minus into minus, plus 1 is equal to 5 minus 3, 2. 8 is not equal to 2. Means in associative property under subtraction is not applicable in integers. The closure property under addition subtraction is applicable in integers. In commutative property is applicable only addition in integers. In associative property also only addition is applicable in integers. Why? Because subtraction is not possible. Then we are taking some examples. We are not getting LHS is equal to RHS side. That's why in properties, in integers we are used closure property and commutative property only addition, and associative property also only addition. Next class we will discuss about remaining properties.